Blender offers several options for mapping UV coordinates, and all these options can be found in edit mode of our mesh object, in the mesh menu, UV unwrap, also accessible by the U hotkey in the 3D viewport. And this is what I mean by several options, all of which offer different algorithms for mapping our UVs automatically. So let's explore these starting from the bottom, which is the simplest option. It's called Reset. So if we click that, you'll notice nothing changed visually. And that's partly due to the fact that these options, these UV mapping options, only operate on selected mesh components. So right now we just have one face selected. So I want to select everything, which I will do by hitting the A key to deselect what was selected, and then A again to select everything. When I hit U reset once more, you'll see that our UV image editor has updated. And what the reset algorithm does is it takes every mesh face of our model and lays it out perfectly square in our UV space. Sometimes it's called 0 to 1 space. It's this grid right here in the UV image editor. And so with this reset algorithm, when it pancakes all of our UV faces on top of each other, it will duplicate the texture that we use onto each face. It's the same concept as when you fill out like a legal document and you have the paper on top, then you have a piece of tracing paper underneath it, and sometimes even another piece of tracing paper underneath that. It often comes in the form of a receipt. And so whatever you write on top, like your name, your address, whatever that info is, it's duplicated onto the pieces of paper below it. That's the same concept with UVs and textures. When you have overlapping faces, that texture information is duplicated. So that's kind of an in-depth explanation of the reset option, but hopefully that also sheds some light on the bigger idea of what UVs are and how they function. So let's move on and go back to our UV mapping menu. Next we have Project from View Bounds. If I click that, you'll see that what it's done is taken the exact perspective in my 3D view from which I'm looking at my object and simply transposes that into a 2D representation through UVs. And you might have noticed that we had two of these options. The next one is Project from View without bounds in parentheses, and this does the same thing. It just includes the negative space around our object from our 3D view. Bounds will simply scale it up to match the border of our UV space. And so this type of UV mapping is very specific, and it's mostly used, let's say if I had a picture that I took with the camera of, let's say, a crate, I could match my UVs to that crate, matching corner to corner and all that, which would in turn project our photograph onto the 3D object appropriately. Just like when you use a projector to put a PowerPoint presentation on a big screen or something like that. That's the same concept here. Let's look at our next option. We have sphere projection. And since we have sphere in the name, the implication is that this is best for a sphere type mesh. So I'm going to jump back into object mode and add a mesh UV sphere. Tab into edit mode there, hit U sphere projection. And right away, it doesn't look great in terms of stretching of polygons and analyzation of our UV layout, but we'll talk about that later. Instead, I want to focus on that anytime you use one of these unwrap operations, remember we have our menu down here that allows us to adjust the settings of our last operation. So for the sphere projection, we have direction options, which by default is set to view on equator. View on poles will give us a different projection, and then align to object will also give us a different projection, all of which have their own uses. We also have align polar ZX and ZY, which is only applicable to the view on poles direction type. And below that we have correct aspect, clip to bounds, which you can see forces all of our UVs to fit on the 0 to 1 space. And below that we have scale to bounds, which scales it to fit in the 0 to 1 space rather than forcing it. And so this mapping algorithm is aimed at spherical mesh objects. The next item on the list is cylinder projection. Again, this implies a specific shape. So let's jump to object mode and add that shape, mesh cylinder. We'll move this up, tab into edit mode, U cylinder projection, where we have very similar options down here for that operator, but you can see how it tries to take a cylinder and unwrap it flat. And again, when I say unwrap, I find it most helpful to think of this as an object wrapped in wrapping paper as a gift. Just reverse the operation and take the wrapping paper off and lay it flat. If you've ever wrapped a present, you know that boxes are quite simple, but anything other than a box is a quite different wrapping experience and it takes more creativity. The same is true with UV mapping. But anyway, like the spherical projection, this cylindrical projection is aimed at cylindrical types. And next we have the cube projection. So if we can go back to our cube, tab into it in object mode, hit U cube projection, and I'll go ahead and scale it to the bounds. And this one does a decent job. However, we do have overlapping faces. And this is noticeable because this face over here is a darker color, whereas this one's a little bit lighter, and that means we have UV components that are stacking on top of each other. So the box is useful because, again, you can think of wrapping paper. You can also think of like a cardboard box, because if you cut those at the corner, they will lay flat pretty easily. So the ideal projection for a box actually comes from our next option, Follow Active Quads. That'll bring up a second menu when we click it, and we'll leave the defaults, click OK. And this is the ideal unwrap for a box because all of our faces are accurate in relation to our 3D object. None of our faces are on top of each other, but they are all connected. This one should make visual sense of how, kind of like origami, this would fold back into our 3D box. So this works great for a cube object. How about a sphere? Let's go to U, Follow Active Quads. And we got an error that said no active face. So I guess that whenever we use this algorithm, we need to have one of the faces be active. So I can hold Shift, click one of the faces to deselect it, and then select it again, and that will make it active. You can see that it looks different from the others. Let's try that again. Follow Active Quads. And that doesn't seem to work well at all with the sphere type. So as you explore this list on your own, you'll learn what works well with which shapes. And the next option in our list is Light Map Pack. So if we click that, this one gives us several different options. We'll just click OK, leave them at the defaults. And this algorithm is similar to the reset algorithm in that it takes all of our faces and lays them out perfectly square, or at least for the most part perfectly square, and then spits them out evenly onto our UV space. I know that this algorithm is aimed at game artists and their workflow, but that too is for a later lesson. Our next option is Smart UV Project. Let's click that. Leave our options at the default, click OK. And what Smart UV Project tries to do is to break up our model into what's called UV islands in order to decrease the amount of UV stretching, a term that we'll get to soon. But this algorithm is actually very useful for creating an automatic set of UVs that can be easily textured. By breaking up our round object over here into several different islands, our model will accept a texture better. And the last option in our UV mapping list is called Unwrap. And this is the most complex algorithm, which I will go over in the next lesson.